right. Hello, everyone, and welcome to this week's Digital Manufacturing Talk. My name is Tyler Fenhouse. I'm the marketing manager for Symphony AI Industrial. We've got a great informational talk lined up for you today titled Mom 360 Composability Best Practices. All right. As you may know, Symphony AI Industrial is a leader in industrial AI solutions and digital manufacturing, plant performance, and optimization, and connected worker. Symphony AI Industrial is a Symphony AI vertical. There are several Symphony AI verticals. You can see them there on your screen. And we are one of the largest, if not the largest, enterprise AI companies with more than 1,600 customers and 3,000 employees. We're going to have a lot of people in the meeting today, so you will be muted throughout the presentation, but the chat is open. So if you have any questions for our presenter today, Chris Ricky, make sure you're getting those questions there in the chat. Also, if you want a recording, we will have a recording shortly after we close up shop here, or a copy of the presentation in PDF form. Also be on the lookout for poll questions. Chris will have a couple of those for you today to kind of guide his presentation. So make sure you are on the lookout and participating in those. All right, he's got a lot to cover this morning, so I'm going to hand it off to Chris and we're going to get this talk started. Chris, take it away.
Awesome. Thanks, Tyler. So as Tyler mentioned, I am Chris Ricky. I'm the product manager here at Symphony AI Industrial for our Mom 360 suite of products. I've been in this space for more than 25 years, and I've worked in a lot of different industries, from discrete to process. I've done automotive and high tech and life sciences. And I live up here in New Hampshire, where it's currently 70 degrees and, as you can see, very sunny. So let's get started. So today we're going to talk about composability, and I want to talk about it in the context of Mom 360 because composability is a great capabilities, but it doesn't solve a business problem, right? The business problem is actually solved by Mom 360, and Mom 360 is an MES offering that we have here at Symphony, and so I'm going to cover a little bit about Mom 360 just so you understand why we care about composability. So we'll cover some of those key capabilities, and then we'll dive deeper into what composability really means to us. And we'll look at a couple demos there, and then we'll follow up with why it matters and what you need to think about if you're thinking about adopting a composable solution. Okay, so at Symphony we have a lot of different offerings in our industrial space, but they're all built on this smart manufacturing platform, and this gives us the ability to connect to those underlying automation systems, though, whether it's very low level sensors or maybe it's IT systems like your ERP or maintenance systems. And we have the capability setting on top of that to provide the use cases around manufacturing and maintenance. So we have our extensibility layers. We have the ability to create and execute and score models. We tie it all together with our knowledge fabric to understand where this data lives and what the current data looks like. And then on top of that, we start building our product suites, right? And so today, again, we're going to focus primarily on the MOM, the manufacturing operations management set of capabilities. So we really think about it with three different main flows. And so with these three flows, we can accomplish most of what people need when it comes to MES. The first one is our process flow, and that's really doing the process enforcement, making sure that your operators and the underlying systems know what they need to be working on, what they should be doing, tracking all of that information through the process. On top of that, we can build our material flow, so understanding what materials are being used, when they're supposed to be used, how much are supposed to be used, what the actuals look like. And then we can also apply quality to this, so do like inline quality inspections to make sure that that the product's being built to specification, and then do something about that if we're not meeting those specifications. So that's really what makes up MOM. And MOM is one of those things. MES is one of those things. I like to say every customer currently has MES. If you have a factory, you have MES running in some fashion or form. It may be on paper, it may be in Excel, but you're doing all of these things in one way or another. And so with Mom 360, we want to digitize that process and make it way better. And one of the ways that we can digitize that process is through composability. If we take a little bit different view of that, we think about the types of resources that we're dealing with in the manufacturing space. We have our assets on the floor, we have our people that are making all this happen, and then we have the various systems that are collecting data and making sure that we're doing the right things. And so our smart manufacturing platform basically brings all these things together. So with our people, we're making sure that those people have what they need in terms of like work instructions and the ability to track what they've done, whether it's through production tracking or maintenance tracking. We have our assets, so we can do things like health monitoring, whether it's condition or model based. We can do performance optimizations on those assets once we understand that underlying data. And then, of course, we can tie it all together with manufacturing analytics, setting on top of that data that, whether it's coming out of the MES system or the APM system or other systems as well, like maybe your ERP or your CMMS. There's a couple interesting KPIs on here. We're doing this right now with lots of customers, to the point that we are creating more than 1 million workflows per month. We're tracking over 6 million data points every day. We're collecting just tons and tons of data per hour for some of our plants. So that's the scalability and the throughput that we have is pretty incredible. So we can support some pretty large processes. So let's start looking at how this all works from a composable perspective. So if we kind of zoom in on the Mom 360 architecture, we like to talk about our hybrid architecture. And we have two main components of this. We have our system of intelligence. This is typically, this part of the system is typically going to run maybe in the cloud or on your data center. And then we have our systems of process. This is typically going to be running on-prem, close to the assets, close to the people that are doing the work. And the value of this hybrid architecture, it gets us a few things. Number one, up at the system of intelligence, it allows us to use that high compute and long-term data archives that you're going to want in the cloud or your corporate data centers. You don't want to have to manage all of that stuff at every plant and have to do local reporting across or go to every one of your plants, if you want to do like cross-plant reporting at time of reporting, right? So our system of intelligence basically provides that centralized place that all of our data resides, and we do all of our enterprise connections. But this is high latency stuff, right? This is not things that are happening in real time. This is where you go to do your analysis and do some of your reporting. And then our system of process running on, again, typically is going to run on-prem within the factory. This is where we're going to have those low latency connections down to the assets. So we're talking, milliseconds down to the automation. This is where your operators are working, where they're pushing buttons and pulling levers to actually make production happen. By separating these things out, what we can do is allow us to use the capabilities of each one of the components to the best of what it brings to bear. So we can do things like have a disconnection between the plant and the enterprise and still continue to have processing happening at the plant. That system of process is going to have enough information, you're going to collect enough information that it can keep processing and tolerate an outage back to the enterprise. But meanwhile, we're going to keep that system of process very small. We're going to be able to deploy that on, depending upon how big your plant is, it could be maybe a 4-core server setting in your plant is all you might need. So you don't have to maintain all of these huge IT infrastructure locally in order to do this processing. From a composability perspective, the way we can start talking about that is, we're that centralized system of intelligence is based upon sets of microservices. So that's going to allow us to do things like spin up new services that we need and spin down services that we're not using, basically composing that architecture of what it is that we need. And then at the system of process, we'll see some of this later. It is a low-code environment where we can build out workflows of small reusable chunks of capabilities to get exactly the type of process that you need on the plant floor. And so by using this architecture and by using the MOM, we're able to provide a lot of different capabilities. So it will become hopefully more evident when we start digging even deeper into the composability, our configuration and extensibility capabilities. We'll touch a little bit upon our connectivity and how that lends itself to composability as well, being able to connect to different types of IT and OT systems. We're able to manage this centrally, so we can, you may have this running at 400 different plants, for example, and we're able to do, push upgrades and maintenance out from a central location. And then, of course, we can put our analytics and insights on top of this, all driven through a generative AI copilot to allow you, get to those results faster with quicker analysis. And we can run on multiple devices, right? So whether you're an operator working at a particular work cell all day long, and so you're on a fixed workstation, or maybe you're some type of maybe a maintenance person that needs to walk around and have more of a mobile experience, we can support both of those. So with MOM, if we look at our big picture vision, our goal here is to be a next generation best in class MOM solution. And we see 4 pillars that really make up that: our composability, our UX, our hybrid deployment, and our AI. We've touched up on a few of these, but let's dig a little bit deeper into composability. That's what we're here to talk about today. Before we get into it, though, let's do our first survey question here. Tyler?
Yep. So we've got our first poll here before we dive into that. For MAMA or MES solutions, is it possible to get out of the box solution that meets your needs? Yes, you've done it before. Maybe we have something but needed to do a lot of customization, or no, our process is so unique, no vendor can do it. So go ahead and click to vote. I will leave this open for a little bit longer. Looks like a handful of you have responded. Go ahead and get those in, and we will move forward here. I'll leave it open for about 3-4 more seconds. All right, so let's take a look. And Chris, it's looking like 20% say yes, they've done it. And the rest of the room, 80%, say maybe we've done it.
All right. Interesting. So I would love to hear more about those of you that have done it, to understand exactly how you did it. I've seen some solutions in the past, or I should say some customer use cases that are easily met with just a straight out of the box solution. But most times it seems like there's and again, it agrees here, right? Most people do some level of customizations. So let's see what we can do about that. So let's dig deeper into this composability, right? So if you look at what composability means, there's kind of a spectrum here of what the different types of approaches that we can take with the architecture to support what a customer might need from an MES or MOM perspective. What has been traditionally for maybe the last couple decades has been the big monolith, right? This is an all-encompassing solution that has everything that you could possibly ever want in it, but probably a lot of stuff that you're never going to use. I think an example of this might be something like a Plex from Rockwell Automation, right? That is a single instance multi-tenant MES solution that runs out on the cloud. And if you're a Plex customer, everything that's in Plex is available to you, whether you want to use it or not. there's lots of buttons and levers that you can pull to try to make it do different things, but you don't modify what it does, right? Because it is that single instance. It does what it does, and it's not going to do anything different. If you want to change, you can submit a change request, and maybe it will eventually get done, and maybe it won't. But that's kind of the extreme example, right? A lot of other MES systems are like this as well. They're big chunks of capabilities, maybe extremely capable, but very expensive usually. And if you want it to do something different than what it just does, then that could be a problem, right? The opposite of that is custom, right? This is basically your start from possibly just a programming language and a database. Maybe you start with an IoT platform, or maybe a SCADA system or something like that, and build your own. I'm seeing more and more examples where customers are having to deal with shadow IT, right? We used to do shadow IT with Microsoft Access. An engineer would get access and build something to solve some particular use case, and it was great, but nobody else knew about it, and the moment he won the lottery, he was gone, and it fell apart. By the way, I did not win the Mega Millions last night, so. But now, instead of Microsoft Access, I see customers, I see people doing things like Power Apps from Microsoft, right? It's different. It's on the cloud now. It's modern technology, but it's still shadow IT, right? And the problem with that is it's very difficult to maintain that and to support that long term. It's you're going to need a crew of people, a crew of developers to manage that. And if you want to standardize, it's going to be extremely difficult, right? Especially if you have multiple plants that have maybe slightly different use cases. You're going to need some kind of a corporate team. So you're looking at hundreds of thousands of dollars a year just in HR, and human resource investment alone, not counting any of the infrastructure and tools and all the other things that they're going to need along the way. Modular sits somewhere in between, right? So modular is kind of like the mini monoliths. So you instead of having just one big block of capabilities, you have maybe 4 or 5 smaller blocks of capabilities, but whether they're going to work together or not is a different question. So trying to tie those things together, if you want your quality information to affect how your process is running, that might be a lot of work, right? And so what we want to do is we want to go a little below modular, but a little above custom, where we can take some reusable building blocks that have a very well-defined set of capabilities, and be able to essentially snap those together into a specific process that's going to satisfy exactly what you need. So how do we do it with MOM? Come on, slide. There we go. So we have a handful of features or components, or I'm not exactly sure what you might want to call them, but the capabilities that we utilize in order to achieve this composability. And there's different levels and different types of composability here, right? So we touched a little bit about on the architecture piece earlier. We're containerizing these microservices up on the centralized component, so that we can spin those things up and spin them down as necessary, allowing us to scale that as we need to. The hybrid architecture lends itself to that as well by segregating the capabilities into the individual pieces that where they make sense. And of course, we have that low code piece down at the edge that allows us to define exactly what we want at the edge. We have our IoT gateway, which we'll dig a little bit into here as well. But this is another one of those pieces that allows us to basically compose what our connection layer might look like. So we can easily replace connectors, whether it's down to level 2, the automation layer, whether it's up to level 4, the enterprise layer, with different types of connectors, maybe using different protocols or different messaging formats, etc. So we'll look deeper into that one a little bit. We also have functional level composability. So we have things like asset classes as an example, right? And so this is where, in your manufacturing process, you have a certain type of assets that have certain sets of capabilities. And so when you go to do your production process, as long as you have an asset that matches the capabilities that you need, you're able to use that. So you can kind of, replace one type of asset or one asset with another asset that has that same contract. If you think about mixers, for example, a mixer is going to have a certain capacity. It's going to have maybe a certain range of speeds that it can support. And maybe it has, some other process parameters that need to define that. So we can use those process parameters and those capabilities of that asset class level to define a generic recipe of how something's going to run. And then at execution time, pick the appropriate asset that would make sense there. We also have something called operation activities, right? So whenever we are performing some activity for a given operator on the floor, the recipe author gets to define what actions are going to happen there. So we have a pre-built set of actions there, and we continue to build out what those actions are. So those actions are small and self-contained, but then they can work together to form out a complete story. And then finally, kind of the ultimate flexibility is our workflow composer, right? Which is where you can take these pre-built, whether it's the operation activities or other pre-built widgets, and drag those onto a workflow to build exactly the process that you need. So what we'll do is we'll take a look at a couple examples, specific examples, and we'll start here with the IoT gateway. So our IoT gateway sits down at the edge, and that is what allows us to connect to our automation layer. And so we supported a lot of different technologies and a lot of different protocols, whether it's connecting down to level 2. And when I say level 2 here, I'm talking about from an ISO 95, layers of the ISO 95 model, down to layer 2 for like OPC or MQTT, connecting to the automation layer, or whether we're connecting up to level 4, the enterprise, through something like Kafka or SQL. The IoT gateway is going to allow us to connect to these different technologies and these different systems, and then it's going to allow us to take the information that's presented on that connector and map that into our unified namespace. So we're going to be able to map that to specific assets, specific asset attributes, for example. And what this does is it allows us to provide an abstraction layer between the business logic that's running the process and the data sources that's just providing the data or reading, sending the data back to some other system. And so a very good example here is where, for example, maybe you have one plant that runs SAP as the ERP system. And so the MES is going to need to exchange, say, orders and inventory with that. Those orders and inventory contracts are pretty well defined. And so from an MES perspective, we don't care where the data comes from, if it comes from SAP or some other ERP system. And so what we can do is have one connector to SAP that collects order information and presents it to the MOM in a consistent fashion. And then maybe at another plant, we would replace that SAP connector with one to Oracle, for example, because the plant came through acquisition and they haven't upgraded to SAP yet. So we can use that same MES system at both places and just trade out the connection to the underlying ERP system. So let's take a look at what an example of what this might look like. So here we have a little video where we have an asset on the factory called production line that's currently using a connector called OPC UA. And what we're going to do is we're going to go into production and we're going to dispatch an order down to the system. And so we pick an order here. We tell it which production line we're going to run on. So we'll run it on that production line 1 and we'll confirm it. At this point, the order or the system is waiting for the confirmation that the production has happened. So the automation is doing its business. So we'll switch over here to our OPC simulator and we'll provide the information that OPC system underneath would originally provide. And so in this case, we can see that once that that OPC message came up, it triggered the production event, and we got that production event message. So now what we're going to do is we're going to change that production line. Instead of using OPC, we're going to use MQTT. And so we can see we're now using the MQTT connector. So we'll do the same thing again. We'll dispatch another order. We'll dispatch it to the same production line. And in this case, instead of, so we're waiting for the confirmation to come back from the automation again, but instead of doing it through OPC this time, we're going to go to MQTT and send a MQTT message. And so we'll paste in our message here, and we'll change it to do the production confirmation message. And once we publish this, the IoT gateway will pick up that message. And let's get it published. There we go. And once that message is picked up, we'll confirm that process, that production process, and record the actual production that happened. So the workflow that's running here in the form of recording this production event, it's the same workflow in both cases. It's exactly the same order. In fact, it's the same production line for us. All we did was just change out the protocol. So that allows us to, very quickly and easily use different types of ways of communicating to our different systems. The contract between the MES and the automation was the same, right? In both cases, we needed the order that was going to be that was being produced against and the quantity of material that was produced. So in both cases, we saw that the OPC was providing that data in one case and the MQTT message in the other. So the contract was the same, but the mechanism was different, right? So that allows us to quickly and easily go into a new plant, put these workflows in place that make sense, and then just wire things up, according to the local conditions. So let's move on. Okay, so the next example that we'll look at here is our operation activities. And so in this case, what we're looking at is our operators on the floor. They're going to be working in an operator console where they're presented with the information that they need. So they're going to see what job they're working on, and then the list of things that they need to do at that particular operation. And so what we do is we have this concept of operation activities where the recipe author can decide what are the processes or what are the actions that need to happen at this particular operation for this particular product. We can do this a couple different ways. It can be kind of ad hoc, where we'll see, and the example we look at will actually be an ad hoc example, where we see a list of actions that can be performed down at the bottom of the operator console. Or we could do it in a sequential or process where we actually drive the operator from task to task through what he needs to perform. And so each activity is going to have a certain set of behavior and certain data that's going to collect a certain UI, and the example that we're going to see, those things are going to show up as those action buttons on the operator console. So let's take a look at an example of this. So here we have our operator console. We've not currently got anything started, so it's all grayed out, but you can see that set of buttons down at the bottom that are, let me get a little ahead of myself here. We can see that list of buttons down here that are the action buttons that will be available to the operator once he gets the order started. So right now we got the consumption, the waste, and the downtime. So as this particular operator that's logged on is an administrator, so he can come over to the configuration and change the configuration of what happens at these operations. So we'll take a look at this particular premix operation that our operator is currently doing. We can see there's the consumption, the waste, and the downtime. So what we're going to do is we're going to turn the inspection on. We're going to decide, hey, we also need to do an inspection process while we're doing this premix operation. So we'll turn that on. Is my thing running? Looks like, there we go. So we'll turn that on and move that. Video is not working very well. turn it on and we'll move that one to the top, right? So we can basically reorder these buttons and turn on different buttons. Once we confirm that and we go back to our operator console, we'll see that change reflect immediately. So we'll go into the order that we want to work on. So now we can see that inspection is now available here, and it's at the top of the line. So that's how we can use that operator or operation-specific actions in order to drive different behaviors at different processes. Okay. The last example we'll look at here from a composability perspective is our workflow composability. So I said this is kind of that ultimate composable capabilities. And so what we see is we have the ability to create these workflows using drag and drop. So we can drag different widgets onto our workflow. They could be pre-built, or we can build them in line, right? And so and this is where the ultimate flexibility comes into play, right? So we can have a handful, or we can have a whole bunch of pre-built widgets. They're going to have certain transactions and capabilities and functions and UIs that go along with them. Or if there is some completely brand new idea that we've never thought of, you can go in and create your own widget and provide some level of scripting behind that to do that completely new thing that nobody's ever thought of. But then you can wire all these things together into a workflow to get your exact process built out. So there's some pretty cool features about this workflow. As we'll see in the example, there's a built-in debugger. So if as you are building out these workflows and you want to test them out, you can do so, and you can see what is happening within that workflow along the way. The other really cool thing about them is they're automatically historized. So as you go through this workflow and data is collected and different things happen, all of that is automatically recorded into the underlying historian. So you don't have to do anything special to understand, from a traceability perspective, when did a certain widget start execution and when did it finish and who did it and what were the timestamps. All of that stuff is automatically historized for you. So let's take a look at what this example might look like. So in this case, we see our workflow up here, and we can see some of our reusable components here that we can drag over onto the workflow. In this case, what we're going to do is we're doing a simple material verification process where we're going to, once we start this process, we're going to get the materials that we need. And so we'll do the get materials. As we go along here, you can see these things turning red, and that's basically the execution of that workflow happening in real time. And then you can see the information down below of the data that's being collected along the way. And so in this case, we're going to scan an apple that we know is going to be invalid. So some invalid material ID is scanned. We're going to see it happen right here where it tries to match it. It doesn't get matched, so it comes down to the invalid material. We'll do a rescan, which takes us back up this way. We'll scan a different material. In this case, we'll make sure that we get a correct one. So we're just going to copy and paste that one over. And then, of course, now whenever we continue that, it's going to come along the good path, and then we'll continue to finish out that workflow. So that's an example of what a workflow might look like, and we can use this, to create very complicated processes. But the good thing is all these widgets that we're building this workflow with are standard widgets. Unless of course you're building your own, which you can do, but there's not necessarily a need to do so. So let's continue on. Okay, so how do we bring all this together, right? So if we think about some of the things that we've seen and some of the things that we've talked about, you can imagine a particular configuration you might have maybe managed at your corporate center. And then you want to go to a plant one where they don't use the standard barcode scanner. So you want to replace that maybe through the IoT gateway to use a different connector to a different type of barcode scanner. And in this case, they also want to add that inspection process. So not only are they doing material tracking, they're also going to turn on that inspection process. But then whenever we go to the next plant, maybe they want to add on some additional reporting that we haven't done before, and they want to change out that SAP connector with the Dynamics connector, right? We're able to do all this, right? The IoT gateway, the operation-specific actions, the low-code composability gives us the ability to do all this basically without having to write any code in a supportable, maintainable, standard way. And we can do that centrally and then push that out to the individual sites. So that we're not having to depend upon having some local IT experts at all these sites to do this work. So why does it matter, right? Standardization, as you continue to go down your digital transformation process, standardization is huge. If you have multiple plants, if you want to understand how does one plant compare to another, you need to have standard processes and standard data that's being collected. And it's very difficult to do if you're doing, custom solutions at each one of those. Or even worse, you have engineers that are just building, tools to manage that stuff themselves. So with composability, allows you to get that that agility to be able to model your specific process in a standard way, but do it, whether you're doing it at the specific plant or you're doing it from a corporate enterprise and pushing it down, and being able to understand, faster time to value and get the data that you need. It also allows you to start addressing some of these problems maybe a little bit smaller instead of having to go with a big bang approach and do this all at once. You can start with something just like process flow and start understanding what orders are running. And then once you get visibility into orders, maybe you want to add materials onto that and start understanding what materials are being used, and then maybe add quality on later. And then start tying into other, additional, maybe start some of these things manually and then maybe add in automation layer, right? So the composability allows you to kind of grow into the final solution that you want to strive for. So who should this matter to? Well, it should matter to everyone, right? As I mentioned before, if you have a factory, you have an MES. The question is it, is it digital? Is it maintainable? Are you paying your engineers that are supposed to be worrying about production to write code? And so if you're in those situations, if you're currently on paper, if you want an older technology and you want to start looking how to get to a more modern solution, then it's something you need to think about. So that comes to our next survey question, Tyler.
All right, fantastic, Chris. All right, next question, and then shortly thereafter, Chris will finish up, and we'll get to your questions. Which aspects of composability are most important? Deployment options, containerization, scalability, etc. Workflow composability, able to draw my own process with standard pieces, plug and play, or all of the above. Go ahead and get those votes in, and we will finish up shop here. I will leave this open for about 10 more seconds. If you haven't responded yet, go ahead and get those responses in. And like I said, we'll have a chance to ask Chris some questions here after he summarizes this. All right, a couple more questions. Or seconds, I apologize. All right, so let's take a look. So 75% of the room, all of the above, and 25% of the room, deployment options. Back to you, Chris.
Awesome, thank you. So all the above makes sense. Deployment options is an interesting one. We didn't cover that one too much on what deployment options really means and how it lends itself to configuration. Maybe that's a good topic for a future DM talk. So, but the 75% at all the above, that makes perfect sense, right? Hopefully, through the course of this presentation, that's become more obvious that, not only is it important, but it's also achievable, right? So just kind of wrap up here, it's not just me saying this, right? Composability is becoming more and more critical to everybody. Gartner says it, Microsoft says it. So hopefully, you have learned something here, and you can see the way forward with how an MES system might be able to support you here. So with that, I'll welcome any questions that you have. If you are interested in learning more, you can certainly reach out to myself, or you can certainly reach out to Mark Besser as well. He leads our sales organization here in the U.S., and he'd be happy to talk to you. So with that, let's see what kind of questions we might have.
All right, fantastic, Chris. Thank you for that presentation. Well done. A lot of great examples there. And I just want to reiterate, I will have a recording for this. So if you want that recording, make sure you're getting that in there in the chat, or a copy of the presentation. While we wait for your questions to roll in, Chris, you can kind of monitor that. I am just going to take the screen for 1 second. All right, so you all just sat in, and we're very appreciative that you did, to one of our digital manufacturing talks. And we have these scheduled out every week, all the way to up to Christmas, so the week before Christmas. So a lot of different topics. We may cover digital manufacturing, MES MOM solutions like we did today, or we might be covering something more like vibration monitoring and hardware, also connected worker. So you're going to want to go and check out what topics we have. Chris has a couple more presentations this fall. So if you enjoyed what you saw today, he does a thorough job. You want to check out the topics that he has coming down the pipeline. All you need to do is go to symphonyindustrial.ai, and then you want to go to resources, drop down to webinars, and you can see what we've got coming, and you can register right here on the page. So we hope to see you at another digital manufacturing talk very soon. And Chris, were there any questions in the chat?
It looks like I was able to answer everybody's questions in the presentation.
Good deal. All right, fantastic. Okay. All right, and with that, we are nearing quarter to the hour, so right on time. Great job again, Ricky. Chris, Ricky, you always do a great job. And look forward to your next presentation. And everybody else, again, we're very appreciative you showed up today, and those who hung in there till the end, thank you very much. And we hope to see you at another DM talk very soon. Have a great day, everybody.
Thank you very much. Bye-bye.